Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions. The mystery of the Fermi Bubbles. NASA discovered two enormous energy structures erupting from the Milky Way's center. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction. Not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In 2010, astronomers analyzing data from NASA Fermi Gamma Ray Space Telescope made a discovery that fundamentally changed our understanding of our own galaxy. Hidden in the gamma ray data from the telescope's first 2 years of operation were two enormous structures, bubbles of high-energy plasma extending 25,000 light-years above and below the center of the Milky Way. These structures, now called the Fermi Bubbles, are symmetrical, clearly defined, and filled with high-energy electrons emitting gamma rays. They are roughly the size of the Large Magellanic Cloud. They were invisible to optical telescopes, invisible to radio telescopes, and had gone undetected throughout the entire history of astronomy until Fermi looked at the sky in high-energy gamma rays. Two objects the size of small galaxies had been sitting above and below our galactic center, completely unknown since before recorded history. The discovery was extraordinary not just for the scale of the objects, but for what they implied. The Fermi Bubbles are the product of some enormous outflow of energy from the galactic center. Something happened there that ejected vast quantities of hot plasma with such force that the plasma expanded in both directions along the galactic axis, inflating two symmetrical bubbles that have persisted for millions of years. But what? The leading candidates are two dramatically different processes. An episode of intense star formation near the galactic center that produced supernova explosions en masse, driving plasma outward. Or activity from Sagittarius A*, the supermassive black hole at the center of the Milky Way, which periodically erupts in jets of energy during periods of active accretion. What makes the Fermi Bubbles particularly interesting is what they reveal about our galaxy's recent past. Recent in galactic terms means millions of years ago, but by cosmological standards, that is extremely recent. It means our galaxy was actively doing something dramatic within a geological eye blink of the present. Sagittarius A* is currently dormant, a relatively quiet black hole consuming almost nothing. But the bubbles suggest it was not always so quiet. At some point within the last 6-9 million years, the center of the Milky Way erupted with an energy output that would have been visible across the entire local group of galaxies. If our early ancestors or their predecessors had looked up at the right moment, they might have seen a jet of light rising from the galactic center, the most spectacular light show in the history of our solar system's residence. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we go further, if you are finding this investigation compelling, please take a moment right now to like this video, drop a comment below with your thoughts, and share it with someone who loves a good historical mystery. If you are watching on YouTube, hit subscribe and tap the bell icon so you never miss a new episode. If you found us through Facebook, tap follow on our page. It takes just a few seconds, and it genuinely helps us keep making these documentaries. Now, let us get back to the investigation. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. The scale of the universe is so far beyond ordinary intuition that even physicists struggle to hold it in mind. The observable universe, contains an estimated 2 trillion galaxies, each containing hundreds of billions of stars. The Milky Way alone has between 100 and 400 billion stars. Conservative estimates suggest that 1 in 5 of those stars has a planet in the habitable zone, the orbital range at which liquid water can exist on the surface. That gives our galaxy alone somewhere between 20 and 80 billion potentially habitable worlds. Against those numbers, the claim that Earth is the only planet to have produced intelligent life seems extraordinary. The statistical argument for extraterrestrial life is almost overwhelming. And yet we have no confirmed contact, no artifact, no verifiable signal. The contrast between the mathematical expectation of abundant life and the apparent emptiness of the cosmos is the Fermi paradox, and it is one of the deepest unsolved problems in science. The paradox has generated dozens of proposed solutions. From the Great Filter hypothesis, some catastrophic barrier prevents civilizations from becoming spacefaring, to the zoo hypothesis, they are watching us, but not yet making contact. To the simulation argument, the universe we observe is itself an artifact. None of these has been confirmed. All of them have troubling implications. The Fermi paradox is not a curiosity. It may be the most important question the human species has ever faced. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. The core evidence surrounding the Fermi bubbles. NASA discovered 2 enormous energy structures erupting from the Milky Way's center is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. The Fermi bubbles were first identified by Meng Su, Tracy Slatier, and Douglas Finkbeiner in a paper published in the Astrophysical Journal in November 2010, using data from NASA Fermi Gamma Ray Space Telescope. The telescope, launched in 2008, maps the sky in gamma rays, the highest energy form of electromagnetic radiation, which penetrate dust clouds that block optical and radio observations. The bubbles appear in the Fermi data as 2 roughly circular regions of enhanced gamma ray emission, one extending approximately 25,000 light-years above the galactic plane and the other 25,000 light-years below, centered on the galactic center in Sagittarius. This single data point, if taken in isolation, might be set aside. Anomalies happen. Instruments malfunction. Researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered the Fermi bubbles have since been detected across multiple wavelength ranges, confirming their physical reality and providing additional information about their composition. X-ray observations by the Rosette and later E-Reseda telescopes show the edges of the bubbles as sharp boundaries between the hot bubble interior and the cooler gas of the galactic halo. Radio observations have identified polarized synchrotron radiation from the bubble's edges, consistent with a population of relativistic electrons accelerated to near light speed, confined within a magnetic field. In 2020, the E-Reseda satellite discovered 2 additional structures in the X-ray band that correspond to the Fermi bubbles, dubbed the E-Reseda bubbles, extending even further from the galactic plane. Now, a skeptic might propose an alternative explanation for this. And that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. The total energy contained in the Fermi bubbles is estimated at approximately 1053 to 1054 ergs, comparable to the energy released by hundreds of thousands to millions of supernova explosions. This energy content places significant constraints on possible formation mechanisms. Any process that created the bubbles must have delivered this enormous energy to the galactic center in a relatively short time, astronomically speaking, to produce the symmetrical, sharp-edged structures observed rather than a more diffuse, irregular halo. The symmetry of the bubbles, one above and one below roughly mirror images of each other, is itself a major clue. It suggests the energy was injected along the galactic rotation axis, which is consistent with a bipolar jet from the central black hole. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, Sagittarius Asterisk, the supermassive black hole at the center of the Milky Way, has a mass of approximately 4 million solar masses and is currently in a very low activity state, consuming only small amounts of gas. However, X-ray observations have shown that the molecular cloud, SGR-B2, located about 300 light-years from SGR asterisk, is currently glowing in X-rays in a pattern consistent with fluorescence driven by an X-ray source that switched off approximately 300 years ago, meaning that SGR asterisk was significantly more active just a few centuries ago. This evidence, combined with the Fermi bubbles, paints a picture of a galactic center that episodically activates and quiets over timescales ranging from centuries to millions of years. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of the age of the Fermi bubbles is estimated at between 6 million and 9 million years, based on the observed expansion rate of the bubbles and the energy content of the relativistic electron population within them. Relativistic electrons lose energy through synchrotron radiation and inverse Compton scattering over timescales of millions of years. So the presence of high-energy electrons in the bubbles today constrains when the electrons were accelerated. This age estimate places the formation of the bubbles in the late Miocene epoch, roughly contemporaneous with the emergence of the Australopithecus genus in Africa, the earliest precursor to the human lineage. The galaxy was erupting as our ancestors were taking their first steps. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding: the E-Reseda bubbles, discovered in 2020 from data taken by the Russian-German E-Reseda X-ray telescope, extend approximately 45,000 light-years in each direction from the galactic center, nearly twice the diameter of the Fermi bubbles. Their relationship to the Fermi bubbles is debated. Some researchers propose they are an older, outer shell from an earlier outburst at the galactic center, while others argue they represent a single structure seen differently in different wavelength bands. If the E-Reseda bubbles represent a separate older outburst, the galactic center has erupted at least twice in the astronomically recent past, suggesting episodic activity that may be a regular feature of our galaxy's behavior. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations. And in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation, and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain the Fermi bubbles. NASA discovered two enormous energy structures erupting from the Milky Way's center. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the active galactic nucleus and jet theory is currently favored by most astrophysicists. Under this model, Sagittarius, an asterisk, underwent a period of intense activity, possibly triggered by the accretion of a large gas cloud or a star, in which it produced bipolar jets of plasma oriented along the galactic rotation axis. These jets inflated the bubbles over a period of millions of years, depositing relativistic electrons and hot plasma that have since been confined by the galaxy's magnetic field. The symmetry of the bubbles is naturally explained by this model. Jets from a rotating black hole are naturally bipolar and symmetric. The E-Reseda bubbles may represent an outer older shell from an earlier and more energetic jet episode. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that the starburst outflow theory proposes that the Fermi bubbles were inflated not by black hole activity, but by a period of intense star formation near the galactic center several million years ago. Massive stars live short lives and die as supernova, each releasing 1051 ergs of energy. If the galactic center experienced a burst of star formation, producing millions of massive stars, the cumulative supernova could have driven a large-scale galactic wind that inflated the bubbles. This model is supported by evidence that the galactic center has indeed experienced historical episodes of elevated star formation. Critics note that producing the observed bubble symmetry and sharp edges through a distributed starburst is more difficult to model than a collimated jet. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that the combined process theory, proposed by several research groups, holds that both mechanisms contributed to the Fermi bubbles. A starburst generated an initial outflow that was subsequently shaped and energized by an AGN jet episode. Under this model, the different energy and morphological features of the Fermi and E-Reseda bubbles may represent different phases of this combined process. This theory is attractive because it reconciles the evidence for both starburst activity and AGN activity in the galactic center's recent history, but it is more complex than either single mechanism theory and is harder to test with current data. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding the Fermi bubbles, NASA discovered two enormous energy structures erupting from the Milky Way's center, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the sharp edges of the Fermi bubbles, visible in both gamma-ray and X-ray images, are among the most significant physical evidence constraining formation models. Sharp boundaries between the bubble interior and the surrounding galactic halo gas indicate that the bubble is expanding as a coherent shock front rather than as a gradually diffusing outflow. This is characteristic of either a single energetic episode, consistent with a jet pulse or a supernova-driven wind, rather than a sustained continuous outflow. If the source had been continuously active, the edges would be expected to be more diffuse. The sharpness argues for a relatively brief and powerful injection of energy. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented the spectral characteristics of the gamma-ray emission from the bubble interior provide evidence about the physical processes occurring within the bubbles. The emission has a spectrum consistent with inverse Compton scattering, relativistic electrons colliding with photons of the cosmic microwave background and boosting them to gamma-ray energies. This process requires electrons with Lorentz factors of approximately 10^3 to 10^4 i.e., moving at 99.9% plus of the speed of light. The presence of such energetic electrons implies a recent and powerful acceleration mechanism, consistent with either an AGN jet or a starburst-driven shock. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the discovery of the E-Reseda bubbles in 2020 provides additional evidence that the galactic center has produced large-scale outflows on multiple occasions. The E-Reseda bubbles' larger extent and different spectral properties suggest they are older and or more energetic than the Fermi bubbles. If the two sets of bubbles represent distinct episodes of activity at the galactic center, separated by millions of years, the galactic center must be characterized by episodic powerful outbursts rather than steady-state activity, a pattern now documented in many other galaxies with active or recently active central black holes. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding the Fermi bubbles. NASA discovered two enormous energy structures erupting from the Milky Way's center. Now, we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. Research on the Fermi bubbles is one of the most active areas in Milky Way astrophysics. The James Webb Space Telescope and the Chandra X-ray Observatory are contributing new observations of the galactic center that are helping to constrain the age and formation mechanism of the bubbles. The Veritas and HESS ground-based gamma-ray observatories are measuring the high-energy end of the bubble emission spectrum to better characterize the electron population within the bubbles. In 2022, a team led by Naomi McClure-Griffiths identified what appear to be radio wavelength structures associated with the Fermi bubbles in southern sky surveys, adding another wavelength window into the bubble's properties. The Fermi bubbles have become a crucial reference point for understanding the relationship between galactic central black holes and the large-scale properties of their host galaxies, a field called AGN feedback. The discovery that even a relatively modest supermassive black hole like Sagittarius * 4 million solar masses, compared to the billion solar mass monsters in distant quasars, can produce galaxy-spanning structures has reinforced the view that AGN feedback is a near-universal phenomenon in galaxy evolution. Understanding what happened at the center of our own galaxy millions of years ago may be the key to understanding how all galaxies evolve and why the Milky Way looks the way it does today. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of the Fermi bubbles. NASA discovered two enormous energy structures erupting from the Milky Way's center, from the historical record through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Fermi bubbles ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process, and the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please help us reach more people. If you are watching on YouTube, subscribe to the channel and hit the notification bell so you never miss a new documentary. If you are watching on Facebook, tap the follow button on our page to stay connected. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment telling us which case you want us to investigate next. The conversation continues. The investigation never ends.